Alright, hello 8th grade. So today we're looking at measures of variation, and specifically we're looking at one measure of variation called the mean absolute deviation. Now, if you're looking ahead at the homework, you may notice some of the problems also mention a thing called the standard deviation. We're not dealing with that right now. We may come back to that if we have time near the end of the quarter, but for right now we're just worried about the mean absolute deviation, which is why you may notice if you were looking at the numbers in the homework, there's one problem where we're only doing part A rather than part A and part B. We might come back to this if we have some time at the end. Alright, so the mean absolute deviation, your technical definition for that, is the average distance between each value and the mean, which is a lot of words. So what we're really going to do to find that is we're going to find the mean, we're going to find the difference, and difference, remember, means we're subtracting, between each number and the mean. And then we're going to find the average of those. So that's the reason we're only doing one of these things rather than both of these things, because this thing by itself has 3 steps, which is also why you might notice if you're looking at the problems, there are only like 5 of them or 6 of them, rather than the usual 10, because each of these are kind of long. So, 3 steps there. We're going to find the mean, find the distance between each number and the mean, and then find the average of those numbers that we just found. That might be a thing you want to jot down, because it's going to be those 3 steps. Alright. I'm assuming you paused the video and jotted that down. If you didn't, just go back like 5 seconds. Okay. So, let's say we got these numbers. We got 4, 8, 15, 16, 23, 42. Bonus for anybody who watched Lost there. Those are the numbers from Lost. Although I'm assuming probably none of you watched Lost because that was out when I was in college, and that's not the main point right now. Okay, so we're going to first of all find the mean. So your first step is we want to find the mean of those numbers. And remember the mean, median, mode, mean, we want to add up all our numbers and then divide by our number of numbers. So we're going to find the mean, so we're going to go 4 plus 8 plus 15 plus 16 plus 23 plus 42. And then we're going to divide by our number of things, which happens to be 6. 1, 2, 3, 4, 5, 6 numbers. Alright, so we're going to take 4 plus 8 plus 8 plus 15 plus 16 plus 23 plus 42 gives you 108 divided by 6 gives you 18. Okay. So that's our mean. Now what we're going to do with that is we're going to find the distance between each of those numbers and our mean. So I'm going to say 4 and 8 and 15 and 16 and 23 and 42. And I'm either going to subtract 18 or I'm going to subtract those numbers from 18. Now, the reason it doesn't matter which one of those you do is we said this was the mean absolute deviation. The absolute part of that means we want the absolute value of whichever way we're subtracting this. So if I go 4 minus 18, I get a negative 14. But we want the absolute value of those anyway, so we're just going to ignore those negatives. So if I subtract 18, I've got a negative 10. If I subtract 18, I've got a negative 3. If I subtract 18, I've got a negative 2. If I subtract 18, I've got a positive. I've got a positive 5 this time. And if I subtract 18, I've got, 24? 24. Okay, but again, what we really want there is we want the absolute value. So I'm just going to throw absolute value signs around all these. Absolute value. And that just means we're going to ignore these negatives. Which is why it doesn't matter whether I do this or whether I did 18 minus 4. That would give you positive 14. We want the positive anyway. Okay, now we're going to take those numbers, we're going to add them up, and we're going to divide by our number of things. So we're going to take 4 plus 10 plus 3 plus 2 plus 5 plus 24 and divide by 6. And 14 plus 10 plus 3 plus 2 plus 5 plus 24 gives you 58. And 58 divided by 6 gives you 9.6 repeat. And just a heads up that some of these you will get decimals. If you get a decimal here, it's going to end up being a rather nice decimal, so like 1 decimal point. The decimal here may or may not be, but 6 repeating, that's not that bad. Because all we were dividing by there was 6, so you're going to end up with something repeating unless it's multiple of 3. Anyway, so that's our mean absolute deviation, which I'm going to abbreviate as MAD. Please do not get too mad. Okay, so that's our mean absolute deviation, and what that means is, on average, our numbers are 9.6 repeating away from that 18. So the average distance away from that 18 is 9.6. Now you may notice up here we have some that are above 18, some that are below 18, but on average they're 9.6 away. Cool. Let's do another one. Alright, and let's do one where it doesn't work out to a nice number before we... There we go. Okay. Yeah, we're good. So, let's say I got these. So, again, the first thing we want to do is we want to find our mean. So, first you find your mean, you find your distances from your mean, and you find the mean of those. Lots of mean. Okay. So, 12 plus 100 plus 50 plus 96 plus 40. And then this time we've got 1, 2, 3, 4, 5 things. So that's the thing we're dividing by. So the thing you're dividing by is always your number of things. So that number is going to change. It's not always going to be 5. It's not always going to be 6. So we got 12 plus 100 plus 96 plus... Oops. Let's get to 15. That's okay. Order doesn't matter. I'm just adding. Plus 40. Gives you 263. And 263 divided by 5. Gives you 52.6. Okay. And again, we're going to take each of these numbers. So we're going to take that 12 and that 100 and that 15 and that 96 and that 40. And this time we're subtracting a 52.6. 6 minus 52.6. These ones you probably don't know in your head. Neither do I. Well, you can figure out that one. Okay. And again, absolute value signs, so we actually want the positive of whatever we end up with there. So 12 minus 52.6 is negative 40.6. And again, feel free to plug this into your calculator. I don't expect you to do this in your head. I mean, if you did, cool, but that's not the main point here. And we got 47.4. And we got, okay, I'm going to 52.6. I don't want to have to redo this because I messed up. 37.6. And 96. Nope. Minus 52.6. Gives you 43.4. And 40 minus 52.6, that one I can do in my head. 12.6, that's negative. And again, once we've got those, if you want to just leave those negatives off to begin with, that's fine. I just want to throw them on there to show you that they are there, but we want the absolute value, so now they're gone anyway. So now we're going to take those numbers, and I'm just going to throw plus signs in between here, so I don't have to rewrite all these. And then we're going to divide by, this time it's 5. Okay, so we got 40.6, oops, 0.6, plus 47.4, plus 37.6, plus 43.4, plus 12.6, gives you 181.6. Divided by 5. And this would probably be a good place to mention that if you're plugging all of this into your calculator, either hit enter like I did before you divide by 5. So either hit enter, find that number, and then divide by 5. Or if you want to plug it all in at once, the other thing you can do is throw parentheses around the top. So if you want to plug that in, this plus that plus that plus that plus that divided by 5, throw parentheses around there, because if you don't, it's only going to take that last number divided by 5, because your calculator is thinking order of operations and it's going to do division first unless you tell it, nope, parentheses come first. Okay, because PEMDAS. P stands for parentheses. And then we're taking 181.6 divided by 5. Which gives you 36.32. So, still a decimal, but a relatively nice decimal. Not like pi, where it's not repeating or anything. Yeah. Okay, and there's our mean absolute deviation, which you may notice is bigger this time because our numbers are more spread out. So you got the 12 and the 15 that are really low, we got 196 that are really high, 40 that's kind of in the middle, closer to our mean. So on average, our numbers are 36.32 away from that 52.6, so they're pretty far away from it on average. You got one that's close, but most of these are pretty far away. So that's what our mean absolute deviation is in the first place, is it's how far our stuff is away from our mean. Okay, one more. More numbers this time. I promise you're not going to have to do this with more numbers than 10. Once you get past that, that's when you program a computer to do it for you. If you really want, I can show you how to do that. All you need is a little bit of Microsoft Excel, or the equivalent in Google. But anyway. Okay. So first thing we want to add up all of our things and divide by our number of things. So we're going to add 22 plus 24 plus 13 plus 16 plus 19. I'm not going to rewrite all of these. I'm just going to add them up. So you get 22 plus 24 plus 13 plus 16 plus 19 plus 42 plus 36 plus 15 plus 27 plus 28 gives you 242. And conveniently, our number of things is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which always guarantees you a rather nice decimal, which gives you 24.2. Okay, now we're going to take each of our things and we're going to subtract 24.2. This is more than I'm going to be able to fit on one line. Okay, so we got 22. And, okay, my purple marker is dying. We got 22, 24, 13, 16, 19. I'm going to leave a little space because I'm going to need it. 42, 36, 15, 27, 28. And then we're subtracting 24.2 from all of those. Minus 24.2 minus 24.2. So none of this is obnoxiously hard, just rather repetitive, and if you mess up something somewhere, you have to go back and see where it was and see if you can find it. So minus 24.2, which is why I really shouldn't say something else while I'm trying to write this. Okay, 24.2. Okay. And again, all of these are really absolute values, so I'm just going to absolute value all of those at once. Absolute value, absolute value, absolute value, absolute value. Okay. Now, we're just subtracting. 282 minus 24.2 is negative 2.2. This is negative 0.2. That is negative 11.2. And again, feel free to plug these into your calculator. This is not the main point. I know you guys can subtract things. Okay, 16 minus 24.2 gives you negative 8.2. I should know that one. That's negative 5.2. Okay, there are positive. 42 minus 24.2. You just have 2.8. And it's like 11.8. Two is 2.2. 28 minus 24.2 is 3.8. Alright. The reason I was looking at that kind of funny is it seemed like a lot of negatives, but most of our positives just happened to end up in the second row, so we're all good. Okay, so now, because, I mean, if you take up all your negatives and all your positives, they should add up to 0, because that's what a mean is in the first place. Okay. Okay, so remember when I said that if you make a little mistake somewhere, it messes up everything? I just went back and edited this video because the 287 minus 24.2 is 2.8, not 2.2. Oops. So that messed up my whole thing. Okay, so once we've got these, we're going to take these, we're going to take the positive versions of all these. So we're going to get rid of that negative, get rid of that negative, get rid of that negative, that one, and that one. And we're going to add them all up. So add them all up, and those add up to 72.4, and then we're taking that 72.4 and dividing by our number of things, which was 10, which gives you 7.24. So on average, our numbers are 7.24 away from our mean. Which, if we're looking back at our numbers, yeah, that looks about right. Most of these numbers are pretty close together. Our average was this. We got some that are bigger, some that are smaller, but most of them are pretty close to that 24.2. So about 7 away. Yeah, that sounds about right. So most of our numbers are about 7.24 away from our mean, which was that 24.2. Okay, so that is a mean absolute deviation. And the reason there aren't as many questions in the homework is because these are kind of long and tedious. So go ahead and check out the numbers in the description below, and I'll see you in the next video.